is a fairly long test. So I want you guys to roll in here ready to roll. I can't remember, but it's several pages. A lot of the pages only have a couple of questions on there because they take up space for like the visuals on there. But it's going to appear like a very long test, and it'll take you guys the duration of the period. So plan tomorrow is we roll in, and you guys just get started on the test right away. Okay? So let's make use of our review time today. That way we are good to go for tomorrow. I'm going to try to start like keeping your assessments and things coming up on the board up here. So I'm just going to have to be good about doing that. But all right, Chris started us off with number 1. What type of angle are we dealing with number 1, Chris? The one that's on the outside, what do we call that? Exterior angle, yep. All right, so in order to find the measure of my exterior angle, I need to add together my 2 remote interior angles. So I got to add together these 2 guys, and then I can set it equal to the outside. So that's what Chris does. He adds together 20 and 30, got 50, and then set it equal to the angle on the outside. So then 2x equals 50. Chris divides by 2 and got x equals 25. So we want to state which theorem that we use there. Okay, so that's the other part. So great job. All right, tell me remember the name of that theorem. Exterior angle theorem, good. All right, there should be no iPads open at this point. All iPads are closed. This is review day to get ready for our test tomorrow. We should be following along on the review. So we would say exterior angle theorem, okay? Again, 30 plus 20 equals 2x. Add together your 2 remote interior angles. Set it equal to your exterior angle. So that's how Chris got x equals 25. Cool. All right, Tegan. I've got these 2 triangles here. I need to solve for x. I think if you let the part, I think we talked about this. I didn't talk about this yesterday, but that number is hard to read, right? Outside the parenthesis. It should be a 5. Kind of looks like a 6, but it should be a 5. If you solve for 5, if you let it be 5, you get a integer answer. If you let it be 6, then you get a decimal answer. Tegan, what'd you do?
I used their angle theorem to find out 55 is equal to 5 times 3x plus 5.
Major key there is third angles theorem. He knows, it's a theorem that we've talked about, but we haven't mentioned a whole lot. But he knows that 2 angles of one triangle are congruent to 2 angles of another. What does that mean about your third set of angles? They're going to be congruent. So then third angles theorem is what he uses. Third angles theorem. And he sets those pieces equal to each other. 55 equals 5 times 3x plus 5. So then 11 minus 5 is 6. Divided by 3 would give you x equals 2. That looks good. Good job. Cool. All right, and then number 3. It says in the diagram, RT is congruent to ST. Name 2 congruent angles. Nobody put this up. You guys tell me. What'd you guys get for number 3? Good. Angle R is congruent to angle S. Great. And then what about number 4? Find X. I didn't put that one up because I figured you guys could do that pretty easily. What type of triangle are we working with number 4? Equilateral. All sides are the same. What's it mean about all the angles? They're all the same. It's equiangular. If they're all the same, then they're equal to what? All 3 would be 180. One of them would be 60 because all the angles are the same. Good. So then I would just set 2x equal to 60. Just do it the easy way. And then divide by 2, you get x equals 30. Otherwise, it's 2x plus 2x plus 2x equals 180, and then solve it that way. Either way, it'll get you the same answer. Okay? All right, what about number 5? What type of triangle are we working with there? Isosceles. 2 sides are the same. So then you would set 3x plus 15 equal to 4x plus 12.
Are those pluses? Are those minuses? Or are those like division symbols?
They almost look like division symbols, but they are indeed plus signs.
That's not.
It's a plus sign.
That's on the test.
On the. When have we ever made it a division sign in a situation like that? It's never been.
I thought it was a minus.
Black bolded is
Okay.
this way.
Got it.
If that's on the test tomorrow.
Do you guys get a negative answer if you let it be minus?
Yeah.
Yeah, that sounds about right. On the test, it will be more clearly printed. And if it's not, and you're like, it could be one or the other, then ask me, okay? And I'll help you out. There's no way it's a minus though. You guys see that stuff that's like that and that? Like it's there. It's just a bad copy of a plus sign. Either way, if we set them equal to each other, I get x equals 3. That's what it looks like. X equals 3. Isosceles triangle. Cool. All right, number 6 is on the back though. Haya did number 6 for us. Haya, what type of triangle are we dealing with number 6? It's equilateral, which means all sides are the same, right? So you just pick your 2 favorite sides and set them equal to each other. So Haya picked 21x minus 3, and then she set it equal to 15x plus 15, and then walk through what you did. Haya, tell us what you did while I take attendance.
So I put the equation of it when I subtracted 15x from both sides, and I added 3 to the sides, which got me 6x equals 18, and I divided both sides by 6.
Cool. And you could have done it differently. You could have picked 2 other sides that said equal to each other, but that looks really good to me. So, all right, cool. We're just missing 2. All right, good job. And then 7, it says prove that those triangles are congruent. All of those sides are slanted. So probably the most straightforward way for me to prove these triangles are congruent would be to find the side lengths of each one of the triangles. How many side lengths would I have to find? 6, 3 of each triangle, right? What would I need to use to find the side length? Bum, bum. So you have to do distance formula 6 times. Show that the sides are the same.
Will you put that up on the board more, distance formula?
Sure. If for whatever reason I forget,
Wait, since it says prove, does that mean we have to do a prove?
nah, just show me the sides are the same. But you don't have to write like a 2-column proof or anything like that for it.
Probably specify that.
Yeah. Okay. We'll keep that in mind. More clarified instructions. All right. Number 8 is a good one though, and nobody did it. All right, tell me about number 8. This is like a really good exercise, and I noticed when I graded your 4.4 to 4.5 quizzes, some of you didn't do as well as I hoped that you would do on this type of question. So it says, tell whether the 2 triangles can be proven congruent. If so, which method would you use? You're picking from one of those 5 methods that we did in 4.4 to 4.5. I'll go over those quizzes at the end if I have time. I'm hoping that I will. Part A. 8A. You guys tell me. SAS, good. What about B? Not ASA. Not SAS. Not SSS, not SSA, because that's not a thing. None. You can't prove them congruent. What we would have if we tried to like fit it into like one of those acronyms would be side-side angle, but that's not one of the 5 that we did. I showed you guys an applet as to why side-side angle doesn't always work. There's only one case in which side-side angle works, and what do we call that? HL. Because when you do HL, which will pop up at some point, you have a right angle, a hypotenuse, which is across, and then a leg, which is next to it. That's technically side-side angle. But again, it only works if your angle is a right angle, okay? So this would be none. What about C? None. What additional piece could you mark on there? Your reflexive side is what you could mark in there. But then it's only 2 pairs of things. It's one side and one angle, and that's not enough. So we'd say none for that one as well. What about D? Good. Side, because you can get that reflexive side down Main Street, and it's going to be congruent. Okay, cool. And then 9, 10, 11, and 12 says state the congruence that's needed to prove the triangle's congruent. You had some exercises like this that was on your quiz as well, too. So you just need to say what additional piece of information you would need. So, like, the problem changes each time. So for 9, it says, given that BC is congruent to EF, use the hypotenuse leg theorem. So what piece of information would we be missing? We need the hypotenuse. So then what that looks like, don't just say a side, don't just say hypotenuse, tell me which sides that you need. So you would need AC congruent to DF. Some of you missed points for that on the quiz because it would say like prove it by side angle side, and it said what piece is missing, and you guys would say a side. It's true, but like you got to tell me which side. Okay. By the way, side angle. If you prove it by HL, you get hypotenuse, a leg, you get a right triangle, a leg, and then a side. That's technically side angle, but it only works for a right angle, so we call it HL. All right, if I reset my picture, and And then it says, given that AB is congruent to DE, so mark that in there. And then AC is congruent to DF, prove it congruent by side, side, side. What piece of information am I missing there? Yeah, so BC would be congruent to EF. So then BC congruent to EF is what I'd be missing there, okay? All right, and then let's do angle, angle, side. This one's a little more open-ended. So if angle A is congruent to angle D, and you know those right angles are congruent, and then it says if angle B is congruent to angle E, which we know from the picture, prove it congruent using angle, angle, side. You can have one or two answers here. You just need to say a set of sides. So you could say like AC is congruent to DF, or you could say BC is congruent to EF. Honestly, either one would work. I'll just put AC congruent to DF. All right. And then for the last one, given that angle A is congruent to angle D and angle C is congruent to angle F, prove them congruent by angle, side, angle. The piece you'd be missing there would be AC and DF again, because that would be the side that's between the two angles that they gave us, okay? All right, 13 I put up there, no one did it. Find X. You guys tell me, what am I gonna do to find X for 13?
Yeah, the 100 equal 180.
Good. So then 3X plus 5 plus 40 plus 4X minus 5. That's what a subtraction sign looks like.
Same thing.
No, it's not, dude. Look, there's no ghosting there. Either way, combining like terms. So then 7x plus 40 equals 180. Subtract 40, 7x equals 140. Divide by 7, and you should get that x is equal to 20. What theorem did we use there?
Triangle.
Very good. Triangle, angle, sum, theorem. If you leave off the angle and just put triangle, sum, theorem, I'm fine with that. All right, what are the three ways to classify a triangle according to their sides? Nope. Good. Scalene, isosceles, equilateral. What's it mean if it's scalene? No congruent sides. What's it mean if it's isosceles? Two congruent sides. What does it mean if it's equilateral? Good, 3 congruent sides. What about angles? 3 ways or 4 ways to classify triangle based on angle measures. Acute.
Acute, right, and then, what was that about equal?
Equiangular.
Does spelling count?
Hasn't so far this year. That's a tough one, I know. What's it mean if a triangle is acute?
Less than 90.
3 acute angles, which would mean all the angles are less than 90. What's it mean if a triangle is obtuse? 1 obtuse angle. All it takes is 1. What's it mean if it's right? 1 right angle. Can only be 1. Can't be more than 1. Same with obtuse. What's it mean if it's equiangular?
All 3 angles same.
Good. 3 congruent angles, which equal what? Cool. Proof time, you ready? So no one did these. We are going through these together as a class right now, okay? So this is when you, as the youths say, lock in. Step 1. Given, right? DF bisects angle CDE. And then the other part is CE perpendicular to DF. They didn't give you a lot with that one. I mean, they gave you 2 pieces of information, but they didn't give you any, like, none of those pieces were congruence pieces, okay? All right. What do we do first in our proofs? Because if I get to these tests tomorrow and I get them back and I only see givens listed, I'm going to lose my mind. What do I start by doing? Yeah, so like vocab from your given, right? What are the two vocab words that we have there? Bisects and perpendicular. When I say bisector, you guys say two equal parts. So we need to find what that is. What is being bisected, a side or an angle? An angle. A side is bisecting an angle, angle CDE. So from that means two congruent angles, okay? I'll get there in a second. What's it mean if lines are, what's the other vocab word? Perpendicular. Then I write that word, but that symbol, that's what that means. From perpendicular lines, what can I get from that? Two right angles. Not necessarily that they're congruent, but two right angles. So let's start marking up our picture, okay? All right, so first one is DF bisects CDE. So CDE is that big angle at the top. So if that angle is being bisected, my two congruent angles are these two pieces right there, okay? So I'm going to use three letters in order to say that. Angle CDG is congruent to angle EDG. Give me a reason. Very good. Definition of angle bisector. Both of you guys had that. Great. So then that's an angle. All right. So then, let me move this because I'm going to need to mark this up. Okay. It's the only thing I can get from that given. So that given is done. Now I need to, Max said I get right angles from CE being perpendicular to DF. Those right angles happen at point G, okay? Now, before I start listing my right angles, I kind of want to look at what triangles I'm talking about here. It wants me to prove triangle DGC. Okay, so then that's this triangle, and then the other triangle is right there, okay? So I need to focus my attention on the pieces of those triangles, okay? So then I'm just going to back that off a little bit. Okay, so I know those angles are congruent. So I'm going to say that angle CDG, no, angle CGD, my bad, CGD, comma, angle EGD are right angles. This is a tricky one. What's our reason? Definition of, good job, guys. All right, super. Now, I can also, since I know they're both right angles, what can I say? Problem, what do you have to say?
I was gonna ask.
Okay, give me a second. I'll be there in a second. If I know they're both right angles, what can I say about them? They're equal, they're congruent. So my next statement is to say that angle CD, or CGD, man, I keep doing that. CGD is congruent to angle EGD. Anybody know what reason that is? Braden?
Oh, I don't have a reason.
Okay.
Question.
We're going to say right angle congruence theorem. One thing you guys could say is all right angles congruent. That's what that theorem says. Braden?
Is there any way to, instead of having to say the right angle, can you just say that CGD is equal to DGE because that's perpendicular line?
No, because the definition of perpendicular, I'm not annoyed that you're asking that question. I'm annoyed that that's the case. Because like having to do a separate step is annoying, for sure. But the definition of perpendicular states that they're right angles. It doesn't say they're congruent. It states that they're right angles. So then we have to use the theorem that says, well, if they're both right angles, then they're congruent to each other. That's a really good question, though. All right, so then that's another angle. So then I have two more steps. I need a side up in here. Good. So then GD is congruent to GD. And then the reason for that is reflexive. All right. Now I have two angles and a side. Is it angle, side, angle, or angle, angle, side? Good, because that side is in between the two angles that I marked, this angle and then that angle, okay? So then because of that, it is angle, side, angle. So I copy down the proof statement, triangle DGC congruent to triangle DGE. Reason for that would be, you guys said angle, side angle. Okay, so here, real quick recap, listed my given. This is me using the vocab in my given, okay? So once I did that, then I was able to get something from that vocab statement. And then from there, I ran out of things to do, so I went to my picture in step 5, okay? So use your vocab and then go to your picture. Julia?
I was wondering, on the test, just like in the earlier chapters, we have to do proof or resolve for like every piece of information.
Haha.
Triangle.
Definition of congruent triangles, yeah.
Yeah, are we gonna have to do that again? Like, are we gonna have to write a proof on the test that's like every single angle?
Mm,
Every single side?
that's a good question. I don't have an answer for you right now. But I can give you an answer at the end of the period if you remind me. I'll see if that's the case. If that were the case, then I would say prove the triangle is congruent by definition of congruent triangles. I'll let you know in a little bit. Yeah. Thanks, buddy. Did it die?
Yeah.
Sorry, buddy. Okay, cool. Let's look at number 17. Okay, so... Oh, this is a really good one. When your math teacher says it's a good one, you know it's about to be a little difficult. The only reason why I say that, I shouldn't say it's going to be difficult. It's an important one because I'm looking at the given. What does it have in there in the givens? Parallel lines. What do parallel lines tell you? Two congruent angles. So if you have parallel lines, it tells you two congruent angles. So it's important that we do something like this. So let's state our givens. AD parallel to BC. AD congruent to BC. And if there was any confusion, they tell you that they are both congruent and parallel to each other. So that's off the board even. All right. Now, before I dive into this proof, I feel it is important to figure, because there's a ton of triangles there, right? I feel it's important that we figure out which triangles we need to focus our attention to. So AED, life-saving device, and then CEB. So those very straight lines indicate which two triangles we need to look at, okay? All right. Okay, so let's use our given. We know that these lines are parallel to each other. Parallel lines give me congruent angles. Which angles are going to be congruent?
BAD.
BAD. Wait, what?
No.
EAD, is that what you said?
No.
Okay.
Angle B, or I guess you have to say BEC, or no, it'd be EBC, and then
The two vertical angles.
The two vertical angles will be congruent. However, there's other ones as well too, which I think Braden's getting at.
alternate interior.
Alternate interior. And there's a couple that you could pick, but Braden's right. Let's say, I think you're trying to do this one and this one, right?
Yeah.
Okay. So let's say those. So angle, okay. B needs to be in the middle. So we would say CBE is congruent to angle ADE. ADE. Alternate interior angles. You guys have two options here. So Braden told us one pair. Can we get another pair of alternate interior angles?
Yes. Yeah.
We could. The ones at point A and point C, right? We got to call them out with 3 letters. So we could say that. We could say DAE is congruent to angle BCE. So then that would be this angle and this angle here. We said BCE. And then that's still alternate interior angles. So I'm not going to put like a separate reason for that. That's still under the same reason. Have I shown enough to prove these triangles congruent?
No.
No, I have. In the given, there was a side, and then we just said 2 angles, right? So then our options are either angle, side, angle, or angle, angle, side. Based on what I marked up in the picture, which one would we use? Angle, side, angle, because I did those 2 alternate interior angles and the side between them. So I would say triangle AED is congruent to triangle CEB. And then the reason for that is what Ryan said, angle, side angle. Now, Dom mentioned our vertical angles. We didn't list them. But what we could have done is we could have just listed one pair of angle from alternate interior angles and then your vertical angles, and then you could have done it by angle, side. That would have been fine too. Either way is totally okay. All right. 18. Yeah, let's do it. Statements, reasons. All right. DE, comma, BC, bisect. I should say each other. What does it mean if they bisect each other? You said what? Okay. You're probably right, though. Say it again, Pradnor. What's it mean if something bisects? Okay. If they bisect each other, how many pairs of 2 equal parts do we get? We get 4 pieces, right? So 2 pairs. So then, let's see. DE and BC bisect each other. So then that means what would be my congruent pieces? So if this line and this line both cut each other in half, then what would be my congruent pieces? DG and GE. CG and BG. Good. So then let's list that. DG congruent to GE, General Electric. And then BG congruent to GC. And then our reason for that would be what? Good. Definition, segment, bisector. Cool. I got 2 sides. I used my givens for all they're worth. Where do I go from there? Go to the picture, vertical angles. So in this case, I got vertical angles. I can't just say G is congruent to G. I will take off a point tomorrow if you do that. Angle what?
DGB.
DGB congruent to angle CGE or EGC. I'm going to say EGC. Doesn't really matter. Either one I would give you guys points for. Vertical angle theorem. That. How about that? Okay.
Can't we just write that?
Nah. Fine. All right. If I put... So I have 2 sides and an angle. I already marked that side. Is that enough to prove the triangle's congruent?
Yep.
Okay. By what theorem? Good. So then I write my proof statement. Triangle DGB congruent to triangle EGC. And then you said side angle side. Theorem. All right. Questions there?
Can you go up to 16 real quick?
For sure. Where you at, Braden? What's up?
I just wanted to see what the theorem was after the right angles.
Right angle congruence theorem or definition of perpendicular, either one of those. Which one you're looking at? Got it. The other thing you could say instead of right angles congruence theorem, that theorem just says all right angles are congruent. So if you wrote that, I would not take off. Okay, 19. I always get excited when there's a midpoint one. Oh! First impressions on this, though.
Yeah, it's bigger.
What, okay, I like the first impressions. What is different about this one?
Oh,
Bless you.
it's not you're not proving the triangles, you're proving the angles.
Good. Not proving the triangles, you're proving a piece of the triangle's congruent, which means we need to use what? CPTT, BD, QRS, TUV. Good, CPCTC. I still have to prove the triangle's congruent, But the last statement will be angle H is congruent to angle E, CPCTC. Okay? Just gonna make myself at home. All right, so we gotta list our givens. This is not comfortable. EF congruent to HF, comma, G is midpoint of EH. I didn't leave myself enough room. Just made it worse by not giving myself enough room. Given. All right, midpoint's an easy one. When I say midpoint, you guys say? Nice. Which equal parts?
GE and then GH.
Good. So along that, what we would perceive to be the base of that triangle, we say that GE is congruent to GH. Great. Reason.
Definition of segment, or, midpoint.
Yes, sir. Cool. I've got two sides congruent. What's the other one they gave me? EF and FH or whatever? Okay, cool. FG equals FG.
Flex it.
Nice.
And then you can do the triangles, because side, side, side.
All right. Braden's come into his own, ladies and gentlemen. It took him a couple quizzes, but he got there. Now, with these, you have to make up your own congruent statement. So, Braden's been running the show. To what congruent statement do you want, Braden?
I would do FEG is equal to FHG. Or triangle FHG. Side, side, side.
We all okay with that? Yeah. We good? Triangles are congruent. Can I say those angles are congruent now? Yep, by CPCTC. So angle H congruent to angle E. It's like as soon as you get the triangles congruent, you just like unlock this like, I don't know, special accomplishment. Then now you can say all the things are congruent. CPCTC. It's just like a game. You just got to look at it like a game. That's all. All right. This one says write the congruent statement for using the diagram below. You just need to say triangle something is congruent to triangle something else. I don't know. Well, what if I said triangle QRS? TUVWXYZ. What would it be?
XEY.
Q. No.
No, YX.
Let's just share.
BYXZ. 6 methods to prove triangles congruent. We talked about 5 for a long time, but there is indeed a 6th, and it's what Julia was talking about. So there's like side, angle, side, 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 angle, side, angle, 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 side, HL, and then the last one, no. Whoa! You can't prove triangles congruent by CPCTC. It's definition of congruent triangles is what it is.
That's
Definition of congruent triangles. The only reason why I made that no so dramatic is some of you guys did try to prove triangles congruent by CPCTC, but you can't do that. It's a result after you've proven congruent. Yes, Liam?
Is a question like that gonna be on the test?
I don't know, maybe. You want it to be? That's easy money points right there, right?
If that was 100 points, that's easy 100.
Yeah. 2 invalid methods to prove triangles congruent.
Not stating everything.
AAA.
ASS or SSA, and then AAA would have been the other one, right? Yeah. I spelled a bad word. All right, let's see. We've got 13 minutes. I've got more proofs here. Probably won't do all of them, but I will do...
I think you should do 4.
I think you should do none.
Yeah, do 4.
4 is intense. What else do we have?
Jay Lewis.
Let me do something real quick. I do. The smell of lunch is coming up through the hallway. What's for lunch today?
Smells like breakfast.
Mac and cheese?
Yeah, definitely.
No, it's breakfast lunch. It's not. It smells like breakfast lunch.
It's mac and cheese, I bet you.
No, it's breakfast lunch.
Real quick survey while I'm pulling up something. What is the top tier lunch here at the school?
Chicken
Oh,
nuggets.
everything. Everything except for.
Do they have good lunches? I've not eaten anything from there. Really?
It's so good.
Easy
My
one.
brother was texting me. He
I'm
never
excited for those
The mac and cheese and chicken, you gotta try it once.
Yeah.
Bloody Alfredo.
Tell me when it is, and then I don't even think I have a code. I don't know how to buy lunch
We
here.
don't know.
We don't know, we
just
don't
got
guess.
it.
You just-
Don't they give you a menu like beforehand or post this? That's not true. They gotta post
It's like
it.
the website, but no one
Something.
posts it.
I don't
okay.
wanna look at it. I just
I
can't.
just wanna be surprised.
Every lunch is good except for one lunch.
What?
The sandwiches. The sandwiches are bad.
What do you mean the sandwiches? Just like a turkey sandwich or
Yeah,
something?
it's like ham sandwiches.
Yeah, that's the one lunch I never eat.
I mean, that's pretty good then.
What?
That's pretty good. If there's one thing that you're not a fan of, and then don't they also have like pizza or whatever you can get probably every
There's a
day?
lot of options.
Is there
Salad.
like two
Sometimes they have
classes?
fries.
Ben said there was
You can
like
get ice cream.
one class.
No, you can't.
Yes, you
Like
can.
there was
No,
one-
you
Yes,
can't.
you can. Yeah, ice cream. That's
You
what
get
Daniel
Friday, and you
is.
had like. bunch
That's
of
great.
classes.
That's why we're not eating this, because we don't cook lunch.
The nachos are pretty
How-
good.
Nachos.
Is the church like attached? to it?
Nacho day is pretty good.
You go?
Seven
Or
zero.
you're Catholic?
The pasta and Alfredo.
What
Mac
did
and
you
cheese.
eat when?
The chicken is just really
Every
good.
Friday.
Christian, can you come over there?
Oh, good.
It's under-
It's under Mac.
Julia,
So it was like next week.
Oh,
It's
yeah.
7 o'clock class.
you do not need to prove anything congruent by definition of congruent triangles.
Okay.
You have to know it's a thing that exists, but I'm not gonna ask you to do that proof. All right, let's, here's what I kinda wanna do.
I'm not playing lightly.
I kind of want to leave these proofs for you guys to. Maybe I can talk about them real quick. Before you have to use segment addition postulate, you're not going to have anything like that on the test. Okay? But let me talk about it real quick. So this one, it says AB, these sides are congruent, these sides are perpendicular. Okay, cool. I might actually do this one for you guys because you have to use HL theorem for this. So I might do this one for you guys real quick just to remind you what that looks like. But the rest of them are not bad. Here's a pair of congruent angles, here's a pair of congruent sides. Vertical angles, angle, side is what you use for that one. This one, angles being bisected. Both these angles are being bisected. And then you get a reflexive side. So angle, side, angle, and then CP. And then that one is segment addition postulate. But I'm not going to make you guys do something like that. Let me do one, pass back your quizzes, give you another review to do work on tonight if you want more review.
That was my legacy. Remember, I just like that. Yeah, you'll be confident like I was when I came actually.
It's supposed to be on the top.
That one then.
How do I know this one's HL theorem? Yeah, so I got that it's perpendicular, right? So I know that these are going to be right angles. I'm just kind of doing some planning ahead of time. And then I can say that reflexive side, right? But if I look at what I have, this would be side-side angle, right? If I tried to prove it like normal. But that's not a thing. Can't do it. So because of that, it's HL theorem. Because can I say my hypotenuses are congruent? Yes, they give me my hypotenuse is congruent. Do I have a pair of legs congruent? I'll be able to say that with reflexive, right? And can I say that they're right triangles? Yes. So because of that, those are the three things I need for HL theorem. So let me show you again what that looks like. Bless you. AB congruent to DB. BC perpendicular to AD. And then that is given. Okay, and then we said that angle ACB, comma, angle DCB are right angles. That would be definition of perpendicular. Here's how the route for HL theorem looked. You first have to state that they're right angles, or you could be given that. What do you state after that? So I need to say that, but I also need to say that it's a right triangle. So then once I know that they're right angles, I'm going to recopy this exact same statement, but I just need to change those three angle marks to a triangle mark. So if I know that those are right angles, then I can say triangle ACB, comma, triangle DCB are right triangles. So then that would be my part for the triangle. I already stated AB is congruent to BD, So there's my hypotenuses. Where did my leg come from? Reflexive. So BC congruent to BC. Reflexive.
Do you not need a reason for?
You do. I just noticed I didn't write anything there. I'm going to put something there. So 4 is reflexive property. Braden's asking about my reason for 3. How can I state that they're right triangles? It would be definition of right triangles. HL's theorem is tough because, we don't do a ton of them. But I showed that they are, hypotenuse is congruent, my legs are congruent, and the triangles are right triangles. So then I can say triangle ABC is congruent to triangle DBC, and then the reason for that would be, good, HL theorem. Albers, go outside. Please. Please. This quiz that I'm giving you right now, listen to me very closely. You cannot walk out of here with this quiz. If you want to study from it tonight, come see me before you leave school, okay? Because I still have a couple people that have to take it. So if you want to study from this tonight, then come see me before you leave school, and then I'll give it back to you.
That's not a smart picture, that's not a smart idea. This is your picture, that's not good. That's not what we want. I think we could- Alright, so that's it. Did you put anything down?
Chris Maxwell. I'm never gonna not call you.
Did you put anything down?
No, it didn't tell you to put anything down. It didn't say right what angle. It said state, and I stated it was put that down.
So angle. No, you can't do that. No, it's not out of your. Hey, you're not leaving.
This was not our best quiz. This was not our best quiz.
Yeah, there's been better.
It's been better. As you guys look through this, I'm gonna pass out your optional review. If I get a chance, I'll post a key for it. This one's not as long.
the same thing.
In this review, I think I'll get it.
I had 3, I had 4. I still get